Hi everybody, we are going to take a look at isotherms. So we're really starting to look at how do we read a weather map. And so we're going to look at how isotherms are drawn. And what are they? Well, really all an isotherm is, it's an area on a weather map that connect lines of equal temperature. So for example, on a weather map you might see 70 degrees and then there's a pocket of 80 and then there's a pocket of 90 inside there, but out beyond the 70s there's the 60s and the 50s. So it's important to realize that if you have lines that are equal, um, they they always loop around each other. They never ever cross each other. They always connect back on themselves. I mean, think about it. If I have a 90 here and then 80 out here, somewhere between that 80 and say a 50, there's got to be all the temperatures in between. Now they could be close together, they could be far apart, but the lines for temperature are always closed, and they loop back onto each other. Sometimes this connection occurs off the maps, we can't see it, but they are always closed in. Um, Isotherms never cross each other. You can't have a 90-degree line here and an 85-degree line here because, well, that doesn't make any sense. They're always some form of irregular parallel to each other. So isotherms never, ever, ever cross. So when they're close together, it's a rapidly changing temperature. If they're really close together, that means it's going to be an abrupt change of temperature from when that line passes over to you to what you're about to get. So like a cold front coming through, all of a sudden it was nice and warm, and then 8 hours later we have cold weather coming in behind us, or a warm front where it was cold and then all of a sudden it's getting warmer. So isotherms that are far apart, then those indicate a really gradual change of temperature over a long distance area. Now normally what I'd have you do is pull this worksheet out and we would be doing this together. So we can, but we're just going to do it in a slightly different way. Let's make this just a little bit larger so it's easier for you to see. And let me get my pen out. And so what we're going to do is we're going to do variations of temperature, and we're going to say that our let's start with a cooler temperature. So let's start with we'll say a blue line. Okay, so we're going to say that our 70 line, because we like color coding, is going to be blue. So of course I have to put a box, a color coding box that would indicate that. So now I need to find my 70s. Well, it's always implied on a number line that if I go from 65 to 75, there should be a 70, and since we don't know exactly which way it's shifting, we're just going to go for the dead center because that's where that would fall naturally on the number line. I could never have a 70 between 77 and 75 because on the number line it doesn't fall there. But I could find a 70 between 65 and 77. I can see a 70 right here. And if I look, I can't go between 77 and 75 or 75 and 79 or 79 and 72 to find a 70. But I can find a 70 between 69 and 72, and it would be a little bit closer to the 69. So I'm going to draw my isotherm, my 70-degree isotherm line. Now the interesting thing about this is, now remember this, they don't have sharp angles. There is no point where a temperature comes at a right angle unless you are literally into a rocked canyon where it's a right angle. Otherwise you're not going to have it that kind of change. So these are not connect the dot lines. These are nice sinuous, in other words, no hard edges, no bumps. So now let's go back here and let's pick another color for our 80. Okay, we have 80 degrees, so that's the next box we want to do, and we're creating our color key code here. Now let's look down here. Okay, I see an 80 here, so I know I've got an 80 mark there, and I can't go between 90 and 87, but I can find an 80 between 87 and 79. In fact, it will be closer to the 79. And I can find an 80 between 79 and 82. I can go there. I can't go between the 79 and 77, but I can go between 77 and 82, and a little closer to the 82, barely. And between 77 and 88, just a little closer to the 77. Now again, we're not going to loop these lines because that will be occurring off the map. So this is a big change in pressure or temperature area. So now let's go the other way. Okay, so I've got a 79 and a 90, so I have to have an 80 there, but it's going to be a little closer to the 79. I can't go between 90 and 89, But I can go between 79 and 80, 95 and 80, again, much closer to the 79. I can't go between 85 and 89, but I can go between, oh, look here. Can I go between 76 and 79? No, but I can go between 76 and 85, and that's pretty close to halfway. So now I'm going to do a curvy line, no hard edges, no connect the dots, please, just nice sinuous curves, and I'm going to label that my 80 degrees. Okay, now one more line. We still need to do a 90 line. So we'll make that red because that's warmer than 70. So 90 degrees is my last isotherm I'm going to draw on this map. Now I see, look down here, I've got a 90 here, and I've got an 89, and I've got an 88. So it's going to look like it's going to force me off this map down here, doesn't it? I've got a 90 right here, and this is hard to see, but it's a 91, so there should be a 90 between 91 and 87. And I've got a 90 here. But interesting, look at this. I have an 89 down here. You can't go down to that because a 90 mark can't go between 93s. But I can go between a 93 and an 89, much closer to the 89 for my 90 mark than 83 by 3. And I can go between 85 and 95. Now then I'm going to be a little closer here. Now if I had more numbers down here, I might actually figure out that I have to kind of go around that, and we would have our nice little loop. And then it would be higher in there. So my 90s are going to be in here, okay? My 80s are going to be between the 80 line and the 90 line. And if I was taking a whole bunch of time, I would make this much prettier, and I wouldn't have crossed over there, but we're not going to be too picky there. And we're going to color in my 70s. Now my 70s are going to be between my 70s and my 80s. And there I have an isotherm map. In fact, if I look down here, I did one years ago where I didn't color it that nice, and sometimes I actually draw this off where I'm not sure because I don't know that data down here. So in this case, I just kind of looped it down and around. But you're going to see the same thing. Here are my 80s, here are my 90s, here's another 80 mark, here's the 70 mark. Isotherms are lines of equal temperature, and they can never ever cross one another. This is a map that in a regular year I would tell you to pull out, and I'd give you a whole list of temperatures from a current weather map from that day. It used to be that the meteorologists at the National Weather Service would take a map like this, and all the different weather stations around the country would call in, and on their little spot on this map they would draw in the weather information. For example, maybe temperature or pressure or sky conditions, and they would create an isotherm map by hand. Now today we have computers that do all this, but it's not a bad skill to understand how to use. So that's what we were kind of doing. We did the Minnesota one, and then we went into this one. Our cold weather was up to the north this day, so it was kind of like big loops all the way around. And if it was all done, and this is here because sometimes we can't remember what our state names are, this is what that weather map for that day looked like. We had, in this case, our 30s, our 40s, our 50s, our 60s, and our 70s, and below that would be higher than 70, but I didn't have that data to add in there. So up here, interestingly enough, if this is our 30s, this is my 20 line, which I guess I should have labeled. So this would be teens, or colder. This is the loop of the 20s coming down. From the 30 line to the 40 line, these are my 30 degrees, so I shouldn't see any 40s in there, nor should I see any 20s. On the other side of my 40 line, I shouldn't see any 30s down below it, nor should I see any 50s included into it, because that's my 50 line. And down here below that is my 50s, and below the 60 line is the 60s. And sometimes you can color in the 70s as higher, but again, not enough information to know when does it become 80 or 90. So we just stopped there. So this is an isotherm map. This shows us areas of equal temperature. And if we look at one from like today, okay, so let's look at a weather map from today. This is the temperatures, and you can tell this is a February not quite, because we wouldn't see this warm, would we, in February? Is this a December? Is this a June weather map, do you think? By looking at the numbers on there, which month do you think we're in? Well, if you guess November, because it's the month we're looking at this, yep, it's a November weather map. In the summer, this would be 70s and 80s. Today, in November, this is the day before you're going to see these notes. So this was the actual one right that you were seeing last night. And we were in the upper 20s, but Canada was in the teens. But do you kind of look and see here the 20s, there's the teens, there's 30s, there's 25s. I could actually draw an isotherm in the 30s. They kind of do color gradation. They don't have really well-defined isotherms on this map, but they do have well-defined colors. And this darker blue is in my 30s, and this green is in the 40s, and the yellow, very thin line, we're looking at 50s. Orange, light orange is 60s, and the dark orange is your 70s. So really, there is one hot spot down here in Mexico along the coast, the Pacific coast, and this inlet where we're seeing some 90s. But even Mexico is only in the 80s and 70s this evening. So as we're looking at this, we can see an example of an isotherm map. And again, we like the really defined lines, but sadly, with everything happening with COVID, the one university that did them has stopped doing them. So I can't show you a really well-defined isotherm map. In fact, even the National Weather Service would link us to that, and it's no longer there. So we are going to look at a slightly less than perfect isotherm map, but the colors do show us what we're looking at. The idea is you can't really have a 70 up here crossing this line. You could have a pocket, but then you'd have to have 60s and 50s and 40s going out to those 30s. So we like to look at the fact that isotherms never cross over one another. This closer they are together, look like right here, this is a really abrupt change in temperature between the 50s to the 70s. The 60s, the 50s is really thin here. So this is an abrupt change of temperature. Where if you're looking up here, this is a much more gradual change from Canada to the teens and 30s, way down to half the country, you're still in the 30s. And then here, look, we're going from 30s to 50s. That's an abrupt change. There's not a lot of 40s marks there, really short, in fact. So again, an isotherm is an area that connects areas of equal temperature. The closer they are together, the more abrupt the change. The farther apart they are, the more gradual the change. And isotherms can never cross over one another. They always have to run close parallel or some kind of parallel to each other. And they generally loop around. If we had the whole continent going up into Canada, we would probably see loops of this. Or if we looked around the whole top of the Earth, going into Europe and Russia, you would see the loops closing. If you have questions, as always, ask.